So, good evening, everyone here at UIST. My name is Uta Wagner, and I'm a third-year PhD student from Aarhus University. And I'm going to present the last paper for today. So, eye-hand movement of objects in near space in extended realities. This work is done with Andreas Asfried Jakobsen, Thierry Feuchtner, and my fantastic supervisors, Hans Gallersen and Ken Pfeiffer. So, here you can see a 3D game Beachhold, which demonstrates quick and effortless drag and drop interaction in a sequence. All the gems appear continuously at a random location in the volume. So the goal is always to move the gems to align three same-colored gems in a cell, so making them disappear and to increase the score. The interaction is done here with our new concept called look and drop. So let me just begin with what is the state of the art. So how are we used to do drag and drop in real life and also in XR? We used to do it just with our hands, so like direct pinch. The principle is that you select the object by moving your hand to the object, grab it with a pinch, and then move it around, right? However, this can be super fatiguing over time. So our optimized version is the combination of eye and hand. And this is the other baseline called gaze and pinch. So the principle here is you look at the object that you like to select, do a pinch gesture, and move it again around with the hand. When you imagine now you wear a device like the Apple Vision Pro, over hours with these techniques, what is the consequence of a lot of hand movement in space? It might be super tiring and fatiguing. So we've tried to improve the technique so that it's less fatiguing for the user. Our concept is called look and drop, and we can split up the drag and drop process into three different phases: selection, dragging, and release. So the selection works like gaze and pinch. You look at your object of interest and do a pinch gesture. Now the dragging starts immediately. You can move around the object just with your gaze at the X and Y dimension. If you like to move your object back or closer to you, you just use your hand with this movement. If your desired position is reached, you can release it with a pinch open gesture. So we therefore investigated direct and indirect mapping variants to figure out which is more comfortable for the users. As you can see here, the plane serves as a kind of tool where the eyes can land on and give the users the relevant depth perception. The depth is adjusted then by the hand movement. In this context, direct means a one-to-one mapping of the object, and it immediately jumps to the level where you do the pinching. So and it feels more intuitive because the user has the full control of it. On the other hand, there is indirect mapping, which is similar to gaze and pinch, and incorporates CD gain. This reduces the amount of hand movement, and even when the pinch gesture is done closely at your body, your torso doesn't block it. So we also found that it's very difficult with the eyes to place the object precisely at the target center. As shown in the video, there's always a slight offset. Also, the user is looking at the target. The object is never placed exactly on it. Therefore, we initially were inspired by size magic technique from 1999, which improves the manual input with gaze. So with magic, it shifts the mouse pointer into the visual attention area on a 2D screen and significantly reducing dragging effort. So one approach is the conservative method. So you look at the target which you'd like to select and then move the hand and immediately jumps to the target. But this wouldn't work in our case, as the hand movement is already required to adjust the depth. The other approach is the liberal method, which wraps the cursor to the gaze position when the user's gaze deviates from the current cursor position by a certain threshold. So, in our work, we face challenges with accuracy and precision. So we further optimize this aspect. As we can see here in the video, the Look and Drop Plus allows precise placement of objects by hand when it's too difficult to do it with just the eyes. But how does it work? So for the coarse movement phase, the gaze is responsible for the X-Y movement and the hand just for the depth. If it's not possible with the gaze to exactly place the object at the target center, even when you try to fixate it, as it's jumping because of the saccades, we have the fine movement phase, where both gaze and hand move the object at the XY. So when you want to be precise, the hand supports and has also control of the X, Y, and Z dimensions. But this doesn't mean that the eyes and hands are separated into two phases. It works still as a whole system. So similar to the magic liberal method, the object always sticks to the gaze position. We have a 4 visual degree area around the target. So the interesting thing is, when we are with the gaze in the target area, the system is still eye-based and not hand-based. However, due to the filter used, it doesn't feel like that. But the eyes aren't moving. But we used a €1 filter to fixate the jitter, and so the eyes move more slowly. And if you look around in this target area, you will probably notice that the object follows with your gaze really slowly. So when you fixate in the middle of the target, the object stabilizes at the point you're looking at. We conducted an empirical study with 24 participants and tested, therefore, 2 different sizes and distances for the 6 techniques. So our findings regarding task completion time, error rate, accuracy, and NASA TLX are the following. There are no significant differences for the task completion time. When we look into which technique is more error-prone, we see significant differences for the look and drop techniques without the manual refinement, as it's too hard to place an object precisely with the gaze. The look and drop plus made it most equivalent like the direct pinch techniques. We also looked into how accurate they were with the error angle in visual degrees. Here we can see that without the manual refinement, they couldn't be that accurate like with the manual refinement. And for the user feedback, it was also significantly less arm fatigue for the look and drop plus techniques. So, yes. As we couldn't see any significant differences for the overall task completion time, we split it up into selection time, course translation time, and reposition time. So we figured out here that for direct pinch, the selection time is longer because the user has to move his hand to grab the object for selection. Whereas for the reposition, they were faster, significantly faster than the gaze-based techniques, because the hand has already the full control of the object. So for eye-hand versus physical movement, our key findings were that look and drop and gaze and pinch have lower perceived physical effort and lower recorded hand motion than the direct gestures without penalty on overall time. Also, the look and drop plus is less error prone than the look and drop, and it was the most preferred techniques for all the users, of 16 of 24 users, sorry. So when we see now the look and drop in general, we ask ourselves for sure, would it probably replace gaze pinch? Well, it's difficult to answer, but I would say it would be a kind of better and a more useful technique for large distances and frequent drag and drop actions. And what I also can say, after using it over hours, when you have learned how to drag objects around with your gaze, you can be really fast with that technique. So this was our work, and thank you very much for your attention.
Thanks for the talk. Mokari from Princeton University. So I was wondering, how do you home? I would assume you do some kind of amplification. You said you have this gain amplification, right, for one of the versions of the implementation. And I was wondering, how do you home the depth, like a neutral position for the hand, so that you would be able to understand how far away the hand is from, how deep it is in. So what is your reference point for the hand when it comes to depth?
I mean, it's everything in arm reach, if I understand it now correctly. So it's like, yeah.
And what would be zero depth, basically? So is it very close? And how do you...
very, very close, yeah.
Okay,
yeah.
And is that like personalized per user?
Yeah, it depends where your headset is. So like the tracking, and then it depends. So, yeah.
Okay, great.
Thank you.
Hi, really nice talk. Sean from NYU. So I'm wondering that if like a user is surrounded by a crowded, like a sphere of a lot of different kinds of objects in a room. So what if, is the user gonna has to face to that object to tell the depth of the hands, or like what if the user just tell their head to another position? So I'm wondering if the z-axis is aligned with the head of the user or just the hand of the user.
Thank you very much for your question. So I know what you mean. So, but in our case, it's aligned with, with the hand and not with the head. But you can do it also with the head. So the alignment, and then the depth, always is aligned to that.
I see. Thanks.
All right, let's give a round of applause to